Alright, for number 14, we're talking about compounding some an investment compounded continuously. So you see the equation, whenever they talk about compounding continuously, we use the PERT equation, P times E to the RT, where P is the principal, R is the rate, T is the time, and of course E is our constant, 2.71828. So we just use the key on the calculator for that. So for the first investment, you have $2,500 at 5% for 7 years. And then the other choice is $2,500 again at 6.5% for 5 years. The question is, which one would give him a better or a greater amount? And then second question, what is the difference? So I've set them up for you right here. So let me simplify. So this is 2,500 times e to the 0.35, and the next one's 2,500 times e to the, when you multiply 0.065 times 5, you get 0.325. So just by looking at the exponents, I know that this one right here is going to be a better deal, right? Because the exponent is bigger. The principal is the same, so that's constant in both investments. But because the exponent is bigger on the first one, that's going to give me more money. Now the question is how much? How much more? So we put that into the calculator, and we're going to put this into the calculator and then subtract. So for the first investment for 7 years at 5%, $3,547.67. The second investment for 5 years at 6.5% is $3,460.08. So like I said earlier, we already knew that the first investment was a better deal. You'd get more money. Of course, it's more time too, but it yields more money. What's the difference would be 300, so you subtract 3,460. So he would get $87.59 more on the first account. The thing is, you'd have to wait 2 years for that. So I don't know. At the end of the day, the higher rate would be better. But to answer the question the way it was given to you, the first one gives them more money, and then the difference in the amount of money would be the $87.59. For number 15, it's again an investment in an account that is compounded continuously. The interest is compounded continuously at 7.5%, $4,000. So that's the way you set it up right here. This is the setup. And so all I did for the second step is just multiply the 0.075 times 10, which gave you 0.75, input it into a calculator, and that gives you, $8,468.00. Now the question is, when will the investment be tripled? In other words, when will Carl have $12,000? This is where you're going to need a graphing calculator. So you're going to input the equation y equals 4,000 e to the 0.075 t, or actually let me take it back. You're probably going to input it in as x, right? And then the second equation, y equals $12,000, and then you're going to see where the two intersect. Okay, and I just put it into a graphing calculator myself, and I got for the time would be 14.65 years. So in a little bit over 14.5 years, you would have $12,000. Okay, so for number 16, we use this equation. I know that there's another equation, but this one would work for the annual compounded annually also. So the n would be 1. So principal is 4,800. The rate is 4.5%, which you have to change to a decimal. The time is 10 years. It's compounded annually, so n is 1. And so you'll see the points, the value substituted into the equation, and then simplified right here. And when you put it into a calculator, you get $7,454.25. So that would be how much money this account would have after 10 years. And then the next question is, when will it be worth $10,000? So again, I'm going to take a graphing calculator. I'm going to graph y equals 4,800, and then 1.045 to the x, and then I'm going to input y equals 10,000 and see where the two intersect, and that's going to give me the time. Okay, so after looking at the graph and then doing the intersection of the two, I got 16.67 years. So at that time, it will be worth $10,000.